I'll give the floor to the next speaker, Anatoly Peshev. Again, collaborative work together with Professor Elena Shoikova. The topic is education enhanced by cloud computing.
Good afternoon. I would like to thank for the opportunity to present the subject actually of my dissertation, which happened a little bit further in time than with us. But still it's actual. Education enhanced by the cloud computing concept. So in general the goal is to study the cloud computing concept and to implement it within university so that we can benefit of all the features. The research was separated in 4 major tasks. First one is to study the concept, what are the benefits, negative effects, features, and etc. The second task is to understand what the university requirements in regards to the IT services are and how this concept can improve that. The third step is to design and implement dynamic data center, which is completely based on the cloud computing technology. And the final step is, of course, all the services which are required and used by the university people to be integrated. So first of all, the definition of cloud. This is the shortest I can find. It's the combination of the remote access to the both software and hardware infrastructure of the data center. This is not something which is figured out in a day or a month or a year. This is the next step of the IT industry evolution. This is completely based on the all the time increasing computing power and the speed of the connections we have nowadays. And of course, completely based on the needs, we have that it's easily to manage service which is centrally located in a data center instead of located locally on the end user computers or workstations. Cloud computing is separated in 3 main layers. So first of all, at the bottom we have all the infrastructure like servers, networks, UPSs, and the data center itself. Based on the virtualization technology which we have for almost 20 years now, we have the so-called infrastructure as a service, where remotely you can access the virtual machines which are provided by the data center and the network connectivity between them. Then we have the platform as a service, which is the same as an infrastructure as a service, but within those virtual machines we have the needed tools to develop certain solutions like development environment, database environment, and etc. And the next layer is the software as a service, which is in time frame is the oldest, and it started all with these internet forums, web-based emails, and etc. In this case, we access only the service as an end user. Topological-wise, we can segment the 3 general cloud computing types to public, hybrid, or private. If the services which are provided to the end users are completely inside the organization or in the organization, then we're talking for private cloud. If it's completely outside the organization, then it's public. And if we're using both of them, then we talk about hybrid cloud. For For example, if the e-learning system in one university is hosted in the university, but for the emails we are using Google Apps, for example, then we're talking about hybrid cloud. What are the main features of the cloud computing concept? The scalability, which is provided by the virtualization and the clustering, which of course gives us the needed quality of service. On certain stages, on certain later stages, if we need more resources, we can easily add them without end users to notice that. Of course, because everything is accessed over the internet, it should be used with user-centric interface. Everything should be accessed either by web browser, simple web browser, or remote desktop, or something simple to use. And of course, everything is price-driven, as we don't have in some cases, as we don't own the infrastructure itself, it's much cheaper to have such solutions. Of course, there are also challenges. There are solutions to avoid those challenges, but it's worth to mention them. In this concept, the performance is not based on the computing power, but on the network connectivity. Still, in some places in the world, the network connectivity is more expensive than the computing power, so this should be taken in mind. The control and the security is also a concern, because actually the data is not physically located in the organization. So, after we know what cloud computing is, we analyzed what the requirements are. In general, as in every university, we have different systems, e-learning systems, staff management systems, repositories, and we need to have one central, easily manageable infrastructure where all those services are. And based on those requirements, we have made 3 case studies for different solutions, cloud solutions. First one is if we're going to use public data center and every university is accessing the virtual infrastructure for that university. In our case, this was not a good solution, because this is a good solution if only we have a concept which is implemented on country level, so that every university within that country has its own virtual infrastructure in that data center. The private data center is located completely within the organization, in our case university. We have one core data center with clustering the second one, where all the systems are provided to the users, and of course third small data center in case of disaster recovery to cover the downtime. And the third case study is the regular software as a service, but having in mind that in university, in every research project, it's good to have, for every research project, it's good to have own hardware, no matter if it's virtual or not. This solution is also not good because it cannot provide such services. So it was decided that our solution will be private cloud within the university, and we have looked at different providers. The first one was Microsoft with their System Center solution. The good part here was that they are covering both management of the services, both virtual machines and services which are provided within them. The second one is the VMware solution. In general, they have better services for managing virtual machines, but they don't provide solutions for managing services within them. So, Microsoft solution was chosen for implementing our cloud. After that, the implementation itself consisted of 5 major steps. The first one is defining the capacity of this data center. Second one is virtualization of creating the virtualization hosts, installing the services in that virtual host is the third step. Creating the storage infrastructure is the fourth one, and the fifth one is creating the network infrastructure. Defining the data center capacity. In our case, we were using only one host machine, and it was able to cover all our needs. In our case, we needed an e-learning system for working with students, cooperation platform for the research projects, authoring tool, and digital repository to store our results. And in this case, we can delegate privileges based on the employees or staff's department. Then we have the services for managing virtual machines and managing the configurations inside the virtual machines, so that if some department needs a pre-configured server with the tools, with these tools we can provide. Having in mind the storage, we have to take care of the capacity. In our case, it was only one server, and of course, the best practice is saying that we need to have a hardware firewall. We were using WatchGuard. The systems themselves we were using for e-learning system Ilias, which is full-feature modern e-learning system with SCORM, LMS learning design, and everything. Integration with the Active Directory was through the LDAP as all the other systems, so we were able to give access directly from the Active Directory. For the cooperation platform, we were using SharePoint Server 2010. It's Microsoft product based completely on their technology, .NET framework, which is expandable. So if we have a lot more requirements than the provided, it was easily developed. There we have all the features needed for projects. For authoring tool, we were using Apple's podcast publisher. The good part here is that you don't need specific hardware, and everything was web-based access. And for digital repository, we were using this base. The evaluation was with more than 200 students from learning point of view, and from research point of view, the platform and the infrastructure of the dynamic data center was core point of 3 research projects. Thank you, and I'm sorry for the accident.
Thank you very much to Mr. Peshev. As you see, it's a real competition. Just one question. The time is going to come. Elena, do you have some questions? If not, thank you very much for your presentation.